All right, we're going to go ahead and get started. So thanks everyone for joining us today for the webinar. We are really excited for our special guest, Microsoft's Julien Dubois here. He is the manager for the Java developer advocacy team at Microsoft, and he's also the creator and lead developer of JHipster project and a Java champion as well. So thank you, Julien, for joining us today. We also have Sergio, who is here from OCI, and he is a member of the Micronaut core development team. And today they're going to be giving us an introduction to Azure Functions Programming Model, which is a model based on triggers and bindings that will assist with responding to events and seamlessly connecting to services, and how well that works with Micronaut. Thank you again so much. And with that, I will turn it over to you guys.
Thank you, Jen.
Thank you.
Yeah, thanks everyone for joining. Thanks, Julien. We are gonna talk about Azure Functions and Micronaut, which is pretty exciting. And it is one of the topics probably more trendy, going serverless with Java. In this case, it's not really serverless because actually Microsoft has a lot of servers for us. So it's kind of the worst naming ever, the serverless computing. But one thing that I want to convey today is, so Azure Functions is beyond HTTP triggers. So it's not only for functions that are going to be called via HTTP, although you can write those, and we will write some of those today. And I think Micronaut Functions plus Azure is a great combo for those kinds of HTTP triggers. But Azure Cloud has a lot of interesting triggers. The usual triggers that you will expect, such as time-based triggers, or triggers when you upload a file, but also like triggers like when you insert a row in a database, or Azure Functions has also really good security integration. And one of the most important appeals of Azure Functions is the billing model. So if you need an application that needs to be there when someone does a request, but you don't need the application to be 24/7 up, you can create a function and you will be billed only when the application, when the function is invoked. And that's especially important because traditionally, at least in my opinion, one of the downsides of Java development is that hosting Java applications was always more expensive than, I don't know, hosting a PHP application. With serverless, that changes the story a little bit. So yeah, let's go to, before going to the panel, so you are gonna need a couple of things, and help me out with these things, Julien. So first thing is Azure Function Core Tools. Can you explain what that is and why do people need it?
Yeah, so when you want to use Azure Functions, you can install it on your computer. So it's a cross-platform. It works on Linux, on Mac. It's even open source. One of the interesting things with Azure Functions is that it's very easy to run it natively on your laptop. So you can test and deploy and debug locally before, of course, sending them to the cloud. And yeah, so everything is open source. So I know even some people who are deploying Azure Functions to Google Cloud. It's possible if you want to. It's a bit might be a bit strange, but at least you are not tied to Azure if that's a concern. And as a developer, of course, it's really nice to be able to develop and deploy locally. I think, Sergio, is that you're going to do it, or otherwise it's really extremely easy with the Maven plugin or the Gradle plugin.
We are going to demo how to run. So just to, as Julien said, this is something that I find really, really cool of Azure Functions, is that you are able to run it locally. Especially for HTTP triggers, it's like it's like you are developing a traditional netty web server application. We are going to see that you are able to run them locally, and it's really easy to debug and to send requests against them, etc., etc.
Yeah, by the way, so I work for Microsoft, but I have a Mac, so I do everything on a Mac, and it works perfectly on a Mac. I honestly, I don't even know how it works really. I just installed it with Homebrew. I just did a brew install, and it's working.
Yeah.
So it's very easy to install and work with it, even if you're not on Windows, which is always surprising to people. I know this.
Yeah, I am. I will be running on a Mac as well. Yeah, I haven't found any problems. I installed it as well with Homebrew, and yeah, really seamless installation experience. Another thing that you need is the command line interface, right?
Yeah,
Uh,
so
Go ahead.
I can introduce you as you want. So yeah, the Azure CLI is our command line interface that we have for everything in Azure. So if you want to create, I don't know, a virtual machine or anything on Azure, well, you can. Basically, you have different ways to do it. You can do it with a portal. So that's what Sergio will do because, well, for a demo, it's easier, and when you start, it's easier because you have like a graphical interface. But otherwise, you have a CLI, and people so either use a CLI directly. So if you want to create a function or a VM or database, you can type the CLI commands, or they use things like Terraform. So there are a number of tools which are sitting on top of the Azure CLI to help you use it. So with Terraform, you can automate everything. So instead of typing all the CLI commands, well, with Terraform, you can automate everything. And well, technically, you are still using the CLI, but in reality, you don't see the CLI anymore, and you've got something which is much more powerful and enjoyable. So I'm guessing today we will mostly see the portal, but as you go with Azure, well, usually the path is you start with the portal, then you after sometimes you are fed up with clicking everywhere, so you use a CLI, and also
Yeah,
sometimes you're fed up of typing all the CLI commands and you use something like Terraform, and then everything is automated and you are happy. But it takes some time to get there because
yeah.
of course, well, you need to understand a lot of things about Azure, and at the beginning it's of course a lot easier to have help and to have like the portal where you've got documentation and everything.
Yeah, for someone getting started, and that was my experience, probably the only CLI command that you will need to run after you install it is AC login, which
Yes.
basically will prompt open your browser, and it will basically, it's like an auth, like an OpenID authentication flow, where basically tell you like you want to authenticate with your Azure account, and you will be up and running. I've registered with, so Azure has like I believe it's 170, I don't know if it's euros or dollars, like free tier. So that's more than enough to test the waters in Azure Functions. And you will see that I am still running on that free tier. So yeah, let's go directly to
uh,
the,
yes, just one thing. When you create an account, you've got, I think it's $200 at the beginning to get started.
yeah,
Well, there are many ways to have more, and for example, if you use EMSDN, well, there are different ways to have more. But for what you are doing here, with Azure Functions and so on, you've got like a free tier for everything. Uh, I
yeah,
don't expect you to pay anything, even if you spent the initial $200. But I mean, it's good to get started with the $200.
yeah,
Use the functions, and you will see that your account is not getting billed. So then you are assured that there is no issue. And yeah, by the way, if you want to use a database, because I see here Cosmos DB, with Cosmos DB now we have a free tier, and so if you use Azure Functions with Cosmos DB, and if you manage that well, you probably don't pay anything.
yeah,
So it's with another thing you have nearby on the left, you have a SQL Server. For SQL Server, you've got now also a serverless option, and also with that, either you don't pay anything or it's going to be a few cents. So it's probably the best options.
yeah.
Uh,
For Cosmos DB, I have seen, so I have no experience with Cosmos DB, but I have seen that there is like a trigger as well.
yeah.
So I assume that will be like when something gets inserted into the Cosmos DB, you will get a trigger.
Yeah, it works both sides here. So you can have your Azure functions that insert data into Cosmos DB because, well, it's a database. It's compatible with, by the way, with MongoDB and Cassandra. So if you want to do NoSQL, it's working. So that's one way to use it with Azure functions. And then the other way, Cosmos DB can send events to Azure functions. Those would not be HTTP events. That's interesting with what we are going to do today. And in that case, it's Cosmos DB that calls you and triggers you. So it can go both ways. You can probably do something very complex here.
Yeah. No, I see some workflows like a user register, you save the user in the database, and that triggers like a trigger to a function, which is the one responsible of sending the
Yeah.
transactional email to basically welcome the user to your service, right?
Yeah. Oh, it's a nice way to go, in a separate thread, instead of waiting for your, I don't know, your controller to do all the things.
Yeah.
The controller just inserts data and then that triggers everything. But the user has got a response very fast. So
yeah,
it's a nice way to scale.
So what I'm going to do is basically create a function. So here I am in the homepage of the portal, so nothing special. And it says create a resource, and I have like a shortcut to function app. I click that. I have a couple of demo functions that I have here. Let me create one. So I am in subscription, free trial, resource group. So the idea here, and correct me if I am wrong, is so this is for billing purposes, right? Or
no,
like
it's really the name is it's like grouping resources. So resources can be a function, could be a VM, could be a database, could be anything. You are grouping them, mostly for logical point of view. For example, you're going here to do some tests. You put everything in the same resource group, and at the end, instead of deleting everything and maybe have some issue because you forgot to delete something, you delete the resource group and everything gets deleted. So it's a nice way to group everything in a logical function, and then you can delete everything very easily. It's a little bit more than just grouping everything, because you can have some limits. Things in the same resource groups can do things together or have some limits. So sometimes you need to put the same stuff in a resource group, but globally, it's just putting like your function, your database, and I don't know, you want to do some. You have a virtual network, and you put everything in the same resource group, and so you can work there. And when you're finished, you can delete everything easily.
Perfect. So let me click create new. I'm gonna say like Micronaut test, or let me say Micronaut resource group. Click OK. I'm gonna give the function a name. I'm gonna put like we're gonna create two functions today. One is gonna be for an HTTP trigger, and another is gonna be for a timer trigger. So I'm gonna create like Micronaut HTTP trigger. We are gonna publish code directly. I'm gonna select. So there are several runtimes. Micronaut being a JVM framework, we're gonna select Java. Yeah. They have support for 11 in preview. I'm gonna select 8, mostly because I have my JDK already set up here. But if you want to test it with 11 in Micronaut, you should be able to generate like a build ready for 11.
I'm having some with 11. It's working fine. I'm surprised it's not GA soon. It should be GA very, very fast. So you can already run with 11. Just one thing about what you had before about Docker. You can run your code inside the Docker container. That's also why you can port your functions to anything else as an Azure. It's a premium feature. You don't have it with a basic tier of Azure functions. Honestly, you're not getting a lot from it because here with when you select Java, so Microsoft is supporting everything. So we update the Java, we update the OS, we do everything for you. You just push your code, so you have a lot less work than doing a Docker container. So, also, it would be probably you probably will have better performance because we are doing some tricks to improve performance for Java apps, which we cannot do for a Docker container because we don't know what you have in your Docker container, of course. So really, my recommendation would be to start with the code, and if you have anything very strange that you want to host, maybe you will go to a Docker container, but it's not the best solution by default, of course.
So I selected as region West US. The only reason I did that was because Micronaut will default to that region. So that's like a setting I don't have to change later on. Next is about hosting. So here I'm gonna say we can deploy in Linux and Windows. I'm gonna select Linux.
Oh, yeah. Yes, by default it's Windows. You need to take Linux. We did some tests yesterday. Linux is your cold start is much better on Linux today. Of course, it can change depending on, so it's not like an official guidance, it can change over time. And maybe, the Windows team will do something great tomorrow and it will be better on Windows. But as of today, Linux is much better. So yeah, it's strange for Microsoft, but that shows how much things are changing at Microsoft. We have better support for Linux than for Windows.
Absolutely. So
fun.
for plant time, I'm going to select consumption, but I have the ability to have premium, which, if I understand correctly, that will basically have like a function always, like a node always ready for me. So it will
Yes,
get rid of the cold startup problem, right?
Yes, if you take consumption, is what people usually call serverless. So everything is stopped and starts when needed, and you are just build on what you use. If you take the higher plans, you can have, you can of course tweak a lot more things. But people usually do those to have functions which are always up. Because they will have better performance. They will not have a cold start. The function is always running. Of course, it costs some money, but the customers I have who do that, it's people who are having like millions and millions of triggers all the time. So the functions are never going to get called anyway. So
Yeah.
it's a I would say bigger enterprise will all be on premium, and I would say, I don't know, startups or smaller enterprise will all be on the consumption plan. It's like two different use cases.
Sure. The next thing that we have to decide is whether we enable applications in sites or not. What should I do?
Yeah, well, you should keep it by default, of course. Well, application insight is here to monitor your app. We're going to have a lot of improvement very soon in Azure Functions here because we have already rolled this in the other parts of Azure, so we can monitor your Java app in a very precise way. So it's going to be a lot better very soon for functions. We have a Java agent, and we can instrument your code and clearly give you a clear view of what's happening in your code. And of course, with Azure Functions, as you are built on your usage, it's very important for you to monitor it, because if you can monitor, you will see, I don't know, the memory you use, everything, and you will be able to tweak your functions better. So, there is also a very big free tier for application insight. So probably you will not pay for it, but even if you pay a little bit for it, it's a very good choice, because you pay a little bit for application insights, but in exchange you will improve your function better, and then you will gain a lot in your Azure function consumption. So it's monitoring is always a good bargain.
Yeah, I 100% agree. So tags, I assume is like if I have like different clients and I want to group like for projects and clients. So here I create a tag tag.
Well, you can do as many tags as you want. So some people tags per, for example, so per client, or you can have a tag for dev, prod, and staging. You can tag also by database. So some people do some, they're going to have like a DBA that is going to update stuff database. So is using that tag, to change everything at once across different resource groups. Or maybe you want to have I know some people, they have like a trigger that deletes everything that is in development during the weekend, because they don't want to pay for development. Well, then you need to tag those correctly. That kind of thing. So, you can do the tags you want.
So it's a way to find resources that you have
select
created.
them easily.
Yeah, got you.
There's no rule here, honestly. It's really up to you.
So I'm going to leave. So this is creating my function. You see the loading bar here. So in the meanwhile, I'm going to open. So the easiest way to create a Micronaut function is probably a Micronaut application or function is to use the, I think I have to click create, is to go to Micronaut launch. So that the URL for that is launch.micronaut.io, or if you go to the Micronaut website, you should have like a button to go to generate a project, right? So we have the concept of features. So the idea is you can click here and say Azure function. We have Micronaut version 2.1 that was released yesterday and has some changes actually. So it's always tricky to do like a webinar the day after a big release. I'm going to say Java 8. I'm going to select Java. So that's the main language, the compiled class language that we are going to be using, the base package, the application. I'm going to say here, let's go with, instead of demo, let's go with HTTP. Let's call the same thing, Micronaut HTTP trigger. And I'm going to select Gradle. We have the same support for Maven. I'm going to select Gradle mostly because I know Gradle better than Maven. I'm going to select Spock. Same reason. I prefer Spock versus JUnit 5. And yeah, I think it's a great test framework. So I'm going to go with this combination. The important bit here is that I selected the Azure function. We have a cool feature called preview here. And this will basically tell me the kind of, basically will preview this is going to generate a zip file. We will preview the contents of that zip file. So there has been big changes in Micronaut 2.1. Specifically, we have now a Gradle plugin to simplify the builds. So I have unzipped the project and I have drag and drop the project into IntelliJ. Why I'm using IntelliJ? Because I'm more comfortable with it, but you can use I know many people, now that we are talking about Azure functions, Visual Studio Code is probably a much better IDE for developing Azure functions. I know that it has like buttons to deploy directly from the IDE.
The plugins are better well, the Azure Functions plugin are better on Visual Studio Code because it's done by the same company. So, Visual Studio Code is also done by Microsoft. But we have a team working on plugins for IntelliJ and also for Gradle, by the way. So typically there's also a plugin for IntelliJ. It's not as advanced, but you can have a look, for example, you can see your functions. You can stream the logs directly into IntelliJ. So it's not as powerful as what you have with Visual Studio Code, but honestly, it's you can click and go to the portal, stream your logs. It's the most basic needs are there, so it's already it's not that bad already.
And also, you are going to see I don't have the plugin installed that you are able to work with your project without even the plugin installed. So yes. let me go through the application that was just created for me. So I have the Micronaut application plugin. So this is this new plugin that we are debuting for Micronaut 2.1, which simplifies the build. So the build now, it seems it has less dependencies. If I do, however, if I do like here, Gradle dependencies, because I have as runtime Azure function, you're gonna see that let me go to io.micronaut.azure. So if you see here, my Azure function HTTP dependency is brought into the mix, and that has like a dependency to com.microsoft Azure functions, right? And this is resolved the 1.0 version, which I believe is the latest stable. And you see here, this is the Azure Functions Gradle plugin. So this is this plugin here. So if I go to Gradle plugins and I search for Azure Functions, Microsoft has a plugin for Azure Functions. And actually there is 1.50, so we need to update the plugin. One of the things that the plugin has is it has an extension. So the Gradle plugins typically, they have like extensions. So let me actually make my font even a bit bigger. So it has like an extension. So this is what you typically will configure. So if you remember correctly, I called my resource group Micronaut test group. So I'm going to basically set my resource group to that value. I called my application name. I already put the same name. I'm in Python tier consumption. I am in West US. If you remember, I told you I'm going to select West US because launch will default to West US. And in runtime, I'm going to change this to Linux because that's what I selected, right? So with this in place, the Micronaut launch put a couple of classes for you. So one of the classes that it put for you is, let me remove this comment so that it's easy to read. It created a function with a method annotated with that function name. So typically in a Micronaut, so this is like a Micronaut application using the Azure function, you will only have like one of these methods annotated with that function name. But especially for other runtimes, you may have like an Azure function with multiple like functions, right?
Yes, you can have, well, typically that's what people in .NET would do. You would have like one function per, I don't know, endpoint that you want to do. You can do the same. But here, what you do and what I really love, and that's very clever. That's the first time I see it. I find it very clever. So you've got a function, and that function, if you look at the parameter, you've got a route in it, and the route, of course, is going to be like the HTTP endpoint. And what you do here is like you have some kind of adapter from Azure Functions to Micronaut.
Correct.
And then it's going to be routed by Micronaut. So what's interesting here is that Micronaut is doing the routing. So everything else will be like normal Micronaut stuff. Because we had a question, and I'm doing the link with a question. Somebody saying, how can you be independent on the cloud vendor? Well, with something like that, because here you're not really coding anything on Azure. You're only coding Micronaut. There is like this little class, which is very simple, which does the binding. But otherwise, you've got nothing specific about Azure here, which is impressive. And in fact, it's not even linked to function because it's a Micronaut router. So you can have even a normal Micronaut app that you port to be a function, and maybe you can then do the opposite if you want to.
Exactly.
That's very clever, honestly.
That's a use case that we have seen, like people writing their applications initially without the serverless deployment in mind, right? They write the apps thinking they are going to deploy them as a fat jar or as a Docker container. But then they realize that they can deploy this as a function, right? So if you see, as Julien was saying, this class here is like, has like it's importing like the dependencies, right? So it's importing like if you see here, this has two parameters. One is like which kind of trigger it has an HTTP trigger. We are allowing get and post request, and then this is the context. So the context will be used like you will get like access to the logger, for example. So we are calling this the Micronaut Azure module ships with this parent class. So this is the only code that for HTTP triggers you will have like is like basically binding both worlds together, like the Azure and the Micronaut world, and then you will write your applications as you will typically do with controllers. So this controllers has an ugly name. So let me change this to something.
Here again, you get nothing specific on Microsoft or Azure Functions.
Yeah, this is like typical. So the controller annotations in a Micronaut controller, etc., etc. Let me add this like demo controller. So we have two routes here. We have one route which will echo example response and another which is like a post request, right? So at this point, I already can do like, I can invoke a Gradle task called Azure. Let me actually do something else. One thing that we have in Micronaut is, in Micronaut 2.1, we are in Gradle, we are leveraging the incremental annotation processing. And this is kind of a bit experimental, so I'm going to turn it to false. I don't want to play with the demo gods too much today. So I'm going to do that, and I'm going to also use the Azure. We have released a 2.0.2 version of the Micronaut Azure module. So I'm going to include those. I'm going to click refresh in Gradle. I'm going to do like Azure Gradle. Maybe I don't know if I have my JVM correctly set up. If not, we will see. Azure functions run. So you don't have to know those tags by memory, right? So in Gradle, you have like this Gradle view where you will have like all the tasks exposed by the Gradle plugin. Or if you are in the command line, you can always do like, and this is called Micronaut HTTP trigger. So you can always do like Gradle tasks. And you see the task name. So you don't have to know the task by name, right? So this is just, so I'm going to execute the task. And this is gonna run the application. So it's already run the application. So this is what Julien was saying before. The development experience with Azure Functions is pretty cool. So this told me that the application has started in localhost 7071 API route. So this route is going to be, in my case, I have demo here. I have the path for this controller is demo. So let me try to do like a car request to demo. And if you see the example response, so that's the example response that is coming from this get request. And if I do like a post request with, it's always complicated to do a post request with her. I believe it's name. So if you check this, so this is a post request, which in the body it takes, by default, Micronaut speaks JSON by default. So this is going to be like it's expecting like a application JSON as the content type, and it's going to take like, it's going to basically take this JSON payload and basically bind it into an object. So this object is defined right here. And if you see, it has only one field called name. So I'm going to say here name, and I'm going to say here Sergio. I'm going to close the, hopefully that's correct.
That's good.
So if you see, then like, hello Sergio, thanks for sending the message. And if you had just one endpoint, this is not really interesting, but the interesting thing is when you start to have multiple controllers. So I can have another controller here. I can have like a person controller.
This is really what I love with what you have done here with Micronaut.
I can have like here like person. I can have like a Pojo. I can have like a person class, for example, which it's introspected. So it's introspected annotation in Micronaut is used like, so we don't use reflection when introspecting the class. So we are able to instantiate the class without the reflection, which helps to generate GraalVM native images, helps in memory consumption as well. It helps also for validation. So I can say here things like, so this is going to be like a required field. So we use the standard JavaX validation constraints annotations, and I'm going to say, I'm going to create a couple of constructors, the empty constructor and their constructor taking the name. I'm going to generate setters and getters, so the typical things that you may expect. I'm going to, so the use case when you will want to use a framework to write a Java Azure function is when you really need to take advantage of framework features, right? So features such as dependency injection or HTTP clients or validation. So I'm going to demonstrate that you can use like dependency injection. So let me create like an interface called name transformer. And I'm going to have, this interface is going to have like just one class, which is going to return like a name transform. And I'm going to call, this is going to be like a required name. So let's say this has to be like not blank, not null, to be friendly to the Kotlin aficionados. I'm going to implement the class. I'm going to call this is going to be my uppercase transformer. So this is going to be a singleton. So in Micronaut, to have like a singleton class in your application context, you use the javax.inject singleton annotation. I'm going to implement the interface. So this is going to be like name transformer. My implementation is going to be as trivial as calling name to uppercase. And now I have like this bin. So instead of in my controller, I'm going to say, I'm going to use constructor injections. This is going to be a final class. Look that I am using the interface, not the implementation. And I'm going to use constructor injection. So Micronaut is going to instantiate the controller for me, and it's going to provide this dependency, which in my case is going to be like the uppercase name transformer, because that's the only bin of type name transformer in my application context. So this is going to be a post endpoint, and this is going to return a person, and let's say indexed, and this is going to take, so I can validate the body as well. So I can say this is valid, and I can say this is person, and I can return here like return new person, and name transform and transform person get name. So it's going to take the name of the input, transform it, and create a new Pojo with the name. So if I stop and the Zoom UI gets out of the way, I'm going to run Azure functions again. So as you see, one cool thing is this starts really fast as well. So this is already started up. So now I can do like a post request. And since I pretty much create the same polio, I can reuse the request. So this is going to be, instead demo, is going to be the person controller. And you see, this is the name Sergio. And we can see validation in action, because if you remember, person is annotated with not blank. I can come here and say, I can send a blank name. And you see this is a 404, which doesn't show in curl, but it's a 404. And this is the copy. It's telling me like person name must not be blank, right? But validation is not just for controller polio parameters. I can also like come here to my name transformer, and I can say this is gonna not just blank, but the regular expression is that this must be Sergio, otherwise it will fail. And let me actually add this into name transformer. So the code is gonna be like this. We are gonna enter here valid person. We are gonna call the transform method, but Micronaut is gonna detect that this method is not being compliant. So there's gonna trigger a constraint violation exception, and that's gonna return in a 404. So if I stop and run the app again, and I execute the post with Julien instead of Sergio, you see that the validations here now match my Sergio. So really powerful local host development for in my machine, right? So really productive local host development. We have also good support for testing, right? So I can come here, and if you see, I have like already like a test here. So for those who are not familiar with Spock, in Spock, you have this kind of BDD test styling where you have like, when this happens, this is what I expect. This is for those coming for HTML. So for JUnit 5, this is like an assert equals true. The only thing is that, or assert equals, sorry. So this is going to be like the same thing in Spock. There is like an implicit assertions in the dem blocks. So this is the same code. So it's basically comparing that this is like returning okay. So this is gonna fail, right? Because I renamed the controller. So if this is now called demo. So if I run the test, let's see the test fail. And this is not like a mock thing. This is like starting the application context of the function and doing the route. So this is like sending not found because it's not found in the route. So if I change this to demo, we actually have in 2.1, which is not really documented, and we have like even a simpler way to do testing, which hopefully I will write a blog post about in the future, which is like, so here you see that I am not starting like a mock server. I am starting the function. You see, I am creating the constructor, and the constructor of the function is the one that is creating the application context. So I could do things like I can verify that my function has an application context, and I can say that this application context contains a bin of type name transformer. So in Groovy, the class literally is optional, so I can remove it. And if I execute the test again, the test will pass. So two things we have seen. We have seen that it's really nice development environment, really productive, and also really easy to test. So now we are going to try to deploy this to production. And if you remember, I think I did the changes already.
Yeah.
So I should be able to run Azure functions deploy. And the Azure team has provided plugins for Maven as well. And probably there are more Micronaut Maven users than Gradle users. So if you want to develop with Maven and you are seeing a lot of Gradle today in this webinar, don't be down, because there is like the same experience is available for Maven.
Yeah, it's done by the same team, by the way, at Microsoft.
So it says
really
successfully deployed to this URL here. So I'm going to copy this URL, and I'm going to do a request. The first one is going to be a bit more slow because it will need the call the startup. So this will be instead of localhost 70. Give me 1 second so I can see my screen. So it's
So
going to be API.person. I believe you can change the context path. So I believe you can remove this API suffix, right?
by default, it's API, that's for sure. Can you remove it? I'm not sure.
I think you
I don't
can.
know. Yes, you can probably.
But yeah, that's something that. So let me
But
do
yeah,
request.
by default, it's always /API.
So you saw the failure because I didn't change so this is still my ego working. So this is still only allows Sergio as a parameter.
Yeah. Oh, we didn't see how much time it took, but it was pretty fast, by the way.
This is the second one. The first one.
Yes, but the first one, we don't know the time it took.
Yeah, if
But
I do
then,
now it's warm, so we cannot check it. But in my experience is like call the startup in a Micronaut Azure function is around 5 seconds, something like that. So yeah, that's one area of improvement that we are going to be working on because, in my opinion, that's the biggest. Not for Azure, but for every serverless provider. That's one area that we are working. Hopefully, with our work and the Azure team.
Yes, well, we also have some internal work to do because what happens when we speak about cold start? Because we saw when you did the Gradle deploy plugin, we saw that you sent a blob. So the blob is basically your code, which is zipped and which is stored into a blob inside Azure. And so when you call your function for the first time, so we allocate a node, we download the blob, and the blob can be quite big for a Java app usually. So that takes time. And then, if it's a Java app, we usually have Java which is pre-warmed. So Java is quite fast here. And then we need to start, of course, the framework. So then probably with Micronaut, you're going to start fast, but still there's some time to start. And if you add all of those, that's what's taking 5 seconds. I'm guessing here that most of those 5 seconds is just downloading the blob. And that's something we need to improve. I'm guessing it's mostly on our side, but that's something we need to have a look at. They don't have that kind of issue in other languages, so there are tricks to improve that, of course.
Yeah, that's a Java issue. So I have here the invocation. So I went in the portal. I went to my function, right? I clicked in functions. Think about the first thing about the application name, right? So this is like the Azure application name. And then inside functions, if you have like a Micronaut HTTP trigger application, you typically will have only one function. So this example trigger, this matches what I have here in the value of the function name annotation, right? And you can see here both the call to startup was like 8 seconds, I believe. And the subsequence was 43 milliseconds, the second request. So the second, after the function is warm, is really, really fast. Where can I see the memory consumption?
If you go to overview, just a little bit above. Yeah, you will have it here. Oh.
Sorry. Yeah. Here, right?
I'm going to do it. No, sorry, it's the other overview. Let's go on top.
So this is cool also. This is like the monitoring of the HTTP codes. So you see 200, okay? And you see 404. So I was not lying when I told you that the validation triggers a 404. You can see it here.
Overview here, yes, because you have the overview of the function and the overview of everything. This is it.
So you have 3 executions, is tell me, and the memory.
We don't see the memory yet, maybe because it's not. You just updated it, and it's taking some time to calculate it. It will appear here. I don't know, after some time.
Yeah, let's go to the next demo, and we will revisit to see if the memory appears here.
Yeah, it will happen. Well, just to tell what we had experienced before, it was like, I don't know, less than, I would say 70 megabytes, something like that. Yeah. What is important here with Azure is that we bill you per memory, by memory usage and time, but memory is per slot of 128 megabytes. So if you are 128 megabytes, you will pay only for one slot. If you are above, you will pay for a second, third, or fourth slot, I don't know. But here, if you are at 70 megabytes, you are sure to be under 128, even if you add more stuff, even if you do some work. So that means you will be billed at the lowest possible level. If you are 70 megabytes, it's extremely good. You're not gaining anything if you go down to 40 megabytes. You're still in the same slot anyway. So that's extremely good.
Yeah, that's pretty cool. I have read the questions that are in the chat. So there is a question from Eric about routing with other triggers. We are going to demo other triggers now. So let's pin this question for now. And then William has a question about, does this have integration to Azure Ad for defining which role can access the endpoint? So we don't. And that's probably something that I would say we should create an issue for. So if I understand the question correctly, I think what the user is saying is if the micro security integration, right? So you can have like, in my controller, I could have like, I don't have the security dependency, but typically you will have here like secure, and you could have like here role admin, right? So if I understand correctly, if we have like, so I don't know, maybe it works out of the box. So
I don't know Micronaut well enough, but yeah, basically you will have with Active Directory, you've got your roles which are assigned to you in the token. So if Micronaut security can just read that and match.
Yeah, I don't know how will the roles be sent. If the roles are sent like in the request authorization header,
yeah.
that will be definitely transformed into the, so that will be present in the request coming to this controller. So that will work. But so I will say, please try it. And if it doesn't work, we can add it to the, maybe to as a module to Micron Security or as a module to the Micronaut Azure, but that's something that we are interested in supporting. And maybe it works out of the box. So Micronaut Security has many different ways of reading like the token, right? So we have support like from reading tokens from an authorization header, from a cookie, from basic auth if you are using basic auth in authorization, from a bearer token in authorization header. But you can also like write a custom token reader. So maybe if we don't support your use case, it's as simple as adding a custom token reader. So I think this probably answers William's question. Let me try to create a new function for the non-HTTP trigger. So I'm going to create this fast. So I'm going to come here and add a new function. I'm going to say this is going to be the same one that we said, Micronaut resource test group. I'm going to say this is going to be a Micronaut timer trigger. I'm going to select Java again, 8, and I'm going to select again West US just to save me some time later. I'm going to go with consumption. I'm going to select Linux again, monitoring. I'm going to go with the defaults. Tags, I'm not going to use tags for now. I'm going to click create in the moment the create button is available. And now I'm going to go to, so you saw that if you want to support HTTP triggers and if you want to support like multiple endpoints, you should go with application here in Micron Launch and Azure Functions. If you want to support like other triggers or you only want to support like one endpoint, I would recommend you to use servlet function because that will have less code, right? We don't have to put like the HTTP layer for the routing. So we are going to go with servlet function and I'm going to select here Azure function as well. I'm going to do the same combo. So I'm going to select again Java 8. I'm going to select the Spock. And just to be clear, I'm going to select here Micronaut timer trigger. I'm going to download the project. I'm going to take the project and zip it. I'm going to deploy it into IntelliJ. I don't know if it has deployed or not. Probably not. Trigger. There you go. So in the meanwhile, my application is ready in Azure. So I'm going to come here and I'm going to do the same trick. I'm going to put incremental to false. I'm going to add the latest Azure. This shouldn't have any effect, but I'm going to add the latest module of Azure Micronaut. I'm going to change this to match what we have here. So my resource group is Micronaut resource group, consumption. I'm going to say here Linux because I get it with Linux. The app name, I think that's fine. And by default, we have like an HTTP trigger here, but I'm gonna change this. So let me remove this and use timer trigger. So these annotations are in this package. So if you focus in the package, you will see that there are many triggers.
Yeah.
Right?
Maybe you can describe a little bit the triggers that are available,
Please.
if that's cool with you. So triggers like a cron, so that's of course very useful. But you can have also triggers. So we told it before on Cosmos DB, for example, when there's a row which is inserted. Well, there are many other systems, but one which is probably the most popular one is something called Event Hub. So Event Hub is a service that is used everywhere inside Azure to send and receive events. And by the way, with the latest version, is now compatible with GMS. So if you are, I mean, as a Java developer, everybody is used to GMS, so you can just use the GMS API to send and receive events. And so that's very popular inside Azure. A lot of people compare it. It's also compatible with Kafka. So it's like what you would do with Kafka. And here what you can do is, so when there is an event arriving, well, then you want your function to run. And I was thinking it's probably the most popular one because it's like connects with everything. So probably the one that people use the most. And and we were speaking, by the way, about call start. I would be interested to have a look at the call start here because your jar is smaller, so maybe it's better. Anyway, call start is not very important for something like that because call start is interesting for an HTTP trigger. When somebody clicks, you want him to have a fast answer. Here, if you say, okay, every 5 minutes or when these events happen, I want this to happen. Well, maybe you will need to wait a few seconds, but it's not very important because it's asynchronous. I mean, it's a lot less important than for HTTP. Doesn't mean we should not improve that, but here the issue is not really existing.
Yeah, absolutely. So one thing, let me go through the changes that I have done. So this is a timer trigger, so I'm not going to return anything. So I have changed my return type to void. I have annotated the function name. I have called this timer trigger. Doesn't matter the name. The important bit is I have changed the annotation of the request parameter, and I have set timer trigger, and writing correctly a cron expression is always risky. So hopefully this will be every 2 minutes. What I have done is, if you remember, I told you before that context can be used like to get like a logger. So I am like logging timer trigger with 4 exclamation marks. So hopefully this is easy to spot. And I am also like logging the request. I have deployed this already. So in theory, so I have deployed by running Azure functions deploy. So nothing. So if you remember, we came here and I set up correctly my Gradle extension to point to my correct function. So in theory, we should see these under functions. I should see like the function with this timer trigger name, which is here. And hopefully, I believe in monitor, we should see the invocations. And it seems my cron job is still not working. Let's give this some time.
Yeah, if it's every 2 minutes, maybe we're not
still not triggered. So one thing that I wanted to discuss in context of the question from Eric, where he says, can I use this routing with other triggers? And what I'm going to show is you can, of course, the beauty of using Micronaut with Azure functions is that you can leverage dependency injection. So what I'm going to do is, to make things more interesting, I have a library here called Euro Rates, which does an HTTP request to the European Central Bank, which publishes daily like an XML feed of exchange rates. So basically it tells you like €1 is $0.8, and they tell you this daily. So this is the kind of thing that you maybe need an Azure function to run like every 24 hours and update your internal accounting software. So this has like a Micronaut HTTP client with retries, with it's using like Jackson XML to basically bind the Jackson response to Apollo. So I think it's a good example of some logic. So I'm gonna add this logic to my function. So I have this dependency. This is like a pet project of mine. So I have this library. It's available in Maven Central. So I'm gonna add the dependency here, as you may add any other library. This is like a Micronaut library. So you can use it in a Micronaut application or outside of a Micronaut applications. But since this is a Micronaut application, you can do things like, I can come here and do like inject. So when you use field injection, that this is what you will do here in the function, you will use like Java act inject, and I can do here like I have to sync in Gradle so that the dependencies that I just added are in the class path. And I can do here like inject, and I can do like error rates. I believe it's called error rates API. So, and now I can call this and just allow me to copy paste the code. So if you check, the error rates is an interface. So it's an interface implemented by an HTTP client, right? So when I do like here in my functions, like currency reference blocking get, this is gonna do like a get request to the European Central Bank, get an XML, bind it into a Pojo, and I'm gonna log it here. So I'm gonna log it basically the change between euro and dollar, because happens to be like the first one is the dollar. So I'm gonna try to redeploy this thing, and hopefully there is like a request here, but it's not.
It's strange that you, as I said, the results are not always, you know, you can have a delay, but you know, we waited quite a long time, so it's a bit strange.
Maybe my cron skills let me down.
You're taking risk. You know, you had a regex in the previous demo. Now you have a cron.
Absolutely, yeah.
You like to live dangerously, but yeah, it looks correct to me. So, well.
So believe me, this will come here. But since it's better to see than to believe it, I have here a function with the same code, more or less, which is deploying microtest cron. Just in case the Micron skills fail me live. So this is the thing that you will see. I have this running. So you see here the call to startups. So I mean, this is not called the startup because this is doing the HTTP request, right? So this is the call to startup plus the execution of the function, which involves doing an HTTP request to the European Central Bank, which God knows how much time it takes to come back. So it's doing all that logic in less than a second. And you see here the exchange rates being printed out. And this is the kind of, so let me make it big so this, those at home are able to see this without.
Yeah, the portal is sometimes a bit painful when you have something like that.
I closed everything apparently.
Yeah.
Functions. So there is also like a command line option to tail the logs of your functions, if I recall, right?
Yeah, well, that's what I usually do with well, you can do it on the command line, of course, but that's what I usually do in my with the plugin. You know, in IntelliJ, you got a plugin and you just click and it streams the logs. So that's why I never do it that way.
So we can see if you see the logic here, so basically it's like almost 1 second to do the HTTP request, because you see this 900 milliseconds. And so this is basically the time of the HTTP request. So essentially the function takes nothing, basically.
Yeah, it's because
all the time is being spent in the HTTP request.
Because your function is out, yeah. But it might be always out because you call it every 2 minutes.
Yeah.
So it's never getting called.
Exactly.
That's something you can do to cheat a little bit.
And we can probably see the memory here because this has been running like for 1 hour. So probably we have like metrics for the memory.
Unless, maybe there's a bug because you have nothing.
Let me see the other. Let me see
It's weird.
the other one.
We had it yesterday. We did it.
Yeah, yesterday we saw the memory.
So it's weird. Well, maybe there's a bug currently. I don't know. We had it yesterday, and it was 70 megabytes if I remember well, which is so extremely good. Otherwise, you can have some more fine-grained vision using application insights, but it's more complicated.
I have to configure it.
Yeah, it's going to be more complicated. Well, if you want to do it well, you need to use application insights because it's far more powerful, and you will have everything there. But of course, it's going to be beyond the demo.
Yeah. So I don't have much else. I think it will be good to leave some time for Q&A. I just want to finish with a couple of things. Important thing for me is don't think functions are only for HTTP triggers. There are many triggers, and Azure functions especially I think they are really well built for non-HTTP triggers because the Microsoft Cloud has really some interesting services, and those are baked into the function support. So there are really interesting use cases. And the two big other key takeaways is if you don't want HTTP triggers, go with serverless function because that will have less code for you. That will only have typically the Micronaut Azure function dependency and the Microsoft Azure Functions Java Library dependency. If you need like HTTP triggers with multiple endpoints, we have the select application and select Azure function, and that will basically add the Micronaut Azure function HTTP, which has a transitive dependency to the Micronaut Azure function. So in general, whenever you go serverless, it's important to have as less code as possible. So if you are not using any Micronaut features, don't put them into the application. So if you are not using the HTTP client, don't add it. So we don't add it by default.
Especially as we talked about called startup. So when the application starts, it needs to download the code. So the bigger your fat jar, the slower it will be. So at the end, it will cost you money. It's well, it will be slower, so that's bad, but it will also cost you money, which is also bad. So two good reasons to be careful with that.
Yeah. I have here some links to resources. So we have like the Micronaut Azure module has documentation about both things. We have in the blog, in the micro.io, if you go to blog, we have like a good, or at least we have a blog post about the support. Couple of things that I have found interesting is, so if you are using the Gradle plugin, check the Gradle plugin Azure documentation, because you have like all the extensions that you saw me there configuring. They are documented there. So I just learned from the documentation is actually quite well. Initially, I deployed to central US, and you have like to put what's the value for central US, and that's in the documentation. So that's really well documented. And then the Azure Java documentation is really nice. Initially, when I started with this, I wanted to see what's the experience of deploying a Java function without Micronaut. And they have really nice documentation, and especially to use Visual Studio Code. They guide you like step by step. So I will definitely encourage you to. So the beauty of using a framework when developing Micronaut Azure functions is to use the framework features, right? To use dependency injection, to use validation, to use configuration, to use HTTP clients. So definitely test it out and let us know what you think. And we have like a community, a Gitter community, where we are open to any request. And of course, the Micronaut Azure module in GitHub is always also a good place to leave like issues. And hopefully we get some traction and we invest more time into the Azure support.
Thank you also for your kind comments on the documentation, because I work on it, and it's also my colleague, so there is a lot of work here. So today's mostly focused on let's say pure Java, but it's only because it's the beginning. And indeed, well, I'm totally with you on that. You, of course, you'd rather use a framework, first of all, because it's going to give you a lot of features that you don't have to code by hand. But I mean, I guess that's been history for like at least 15 or 20 years. So everybody should understand that. The other reason also here is that you're going to be independent from the underlying provider. As we saw here, you have like one class to bind between Azure and Micronaut, and then it's all Micronaut code. So you are not tied to one cloud provider or even one type of application. It could be like a normal, you can easily transform your app into I would say, a normal app that runs on a VM on another cloud provider. So it's also interesting because I know a lot of people are when talking about functions, by the way, that's one of the questions. That's the first question from Jim. The first question we always have about serverless is you want something which is very proprietary. So that frightens people. You know, they don't want to be tied into a provider. So the first answer is, of course, to use a framework to abstract you from that. The second thing also that we provide on Azure, and that's very specific to Azure, is the whole Azure functions that we've used here is open source. And it's very easy to deploy it as a Docker image, and the Docker image can, as any Docker image, can run anywhere. So you could run this on Google Cloud, on Amazon, and so you are not tied to Azure at all because you can just walk away as easy as you want. So two answers to that question. Azure Functions is open source for that, and if you have a framework like Micronaut, well, you're not using much API anyway from Azure Functions, so you can easily go and run your functions elsewhere if you want to.
Yeah. We have a question from William, which I believe it's a question that you will be able to answer. I mean, for sure, you will be able to answer much better than me. He says, I saw there is a trigger for blob storage. We can write a file to blob storage directly with it. And he says, and I assume it supports data lake Gen 2 as well.
So I'm not trying to understand this question correctly because for blob storage, what's happening is that when somebody sends a file to blob storage, then that triggers a function. It's like, because he said we can write a file directly with it, it's a bit strange. It's the opposite. You write a file in blob storage, you send it. There's like tons of ways to do it. And when the files arrive, then the function starts. It's like when you're doing, I don't know, you have invoices coming, you store your invoices in blob storage, and each time an invoice arrives, then it triggers something. It's going to trigger an alert or anything else. So.
So I don't know the answer for sure, but I am pretty sure in the trigger example, for example, I am sure you could probably create like a CSV file with the exchange value and save it directly to blob storage.
Oh yes, and then you can write. Well, after that, it's like the Azure SDK. You can do, your Azure function. You can do anything with it, and including using the Azure SDK to write something else. Yeah. And you can do something extremely complex that way. Like you receive a blob, then you write another blob, and
so I think that there is a typical use case for that kind of thing that William is asking is for like preprocessing. So you get like you upload an image to blob storage, you get the trigger, you create like a thumbnail of the image, and you save it again to blob storage.
Yes, typically. I will need to give you some. Well, I need to have a look at the links for that. But at recent Microsoft conferences like Ignite or Ready, we had big customers coming and showing what they were doing with Azure Functions. So I'm not telling names because I don't remember which one is public and which ones are private. But basically, you've got like huge e-commerce companies, but really huge ones. And it's like, when a user registers or something like that, so there's an HTTP trigger for that. But then there's like 20 or 30 other functions that are running after that, because that first event is launching a lot of other things, like sending him an email to tell him that he has registered and creating data for him in a CRM system and so on. So it's a lot of people are in fact using this to to like explode the number of different features that you want from when one user comes. You want to do like 30 different things with 30 different systems, and that's how they do it. And the beauty of it is that it's scaling without doing anything. So that's my big customer in France. That's what they do. It's like they're not they're mainly using Azure functions for scaling. They have nothing to do. You just put your function and that's it. So that's a huge plus. I'm saying we have, hang on, is after the fact or before the fact storing into blob storage? So from Alexander, yeah, I think it's the same thing. So it's, you can have a trigger when something is stored in blob storage. So storing a blob runs the function, and then running the function can also, when the functions run, you can also store things in blob storage. So it's like both. And
so then we have a question now from Eric about GraalVM.
Eric, you got the best question, the one that everybody waits about. We should have told it at the beginning, because we would have like everybody staying.
So we have plans to support. So Azure has custom handlers. So we are not there yet, but they have like the ability to create like a custom handler, and we should be able to have like the ability to deploy like a GraalVM image of your function to Azure, but we are not there yet. We have an issue actually in GitHub, Azure module. So if you are interested in that, I will say thumbs up that issue.
Honestly, you will have it. It's very easy. From what I've seen, it's very easy for you. It's I have no doubt you will have GraalVM with Micronaut on Azure. Then the tricky part is what you talked about, is custom handlers. Here with Java, so you got a specific Java worker, and we do some tricks to improve performance. We cannot do the same for a custom handler because we have no idea what's inside it. So that's the first issue. And the second thing we talked about cold start is that we need to download your function to the node in order to run it, of course. And with GraalVM native image, well, the native image is still a bit big. So that's also taking time. So for Java app, we can do some tricks. We're not doing them yet, but we're just discussing that before. Because, for example, with Maven, I don't know, the Micronaut dependencies could be cached with the Gradle cache. So maybe we can do tricks in Java that we cannot do with GraalVM because everything is bundled into the binary. So I'm totally sure you will have a GraalVM native compilation with Azure Functions and GraalVM, because honestly, it's easy to do. I have no doubt about that. Then will the performance be good? It's another issue, because so the time to download the app and the usage of custom handlers are going to slow down things. So you might not be as happy as you should about startup time. Well, you will be probably for memory, but already here you're using less than one slot of memory. So if you use 70 megabytes with Java, but with GraalVM you use 20 megabytes. I mean, probably it's good for the planet to use less megabytes, but for your billing, it's going to be the same because you are in the same slot. The slot is 128. So GraalVM is already so performant in Java, so that you are already in the slot. So you will not be billed less because you are already at the minimum. Yeah, I have huge hopes for GraalVM. I really believe there's a great future for it. Then here there's still quite a lot of work to do. To get it working, it's fine, but to get it working well, to have something better than you have with Java, that's more work, clearly.
Yeah, there are a couple of things. So one thing is the deployment story. Another thing is how are we going to test those? How are we going to do like this integration test of GraalVM native images, right? Because GraalVM native image takes some time. So there is going to be, we have all the framework developers, the cloud providers, but also like the regular developers. We probably have all of us to really embrace continuous integration, because those native image tests will probably have to be run in continuous integration servers, because nobody's wait like 3 minutes to run the test in their computer. So as Julien said, I am also optimistic, but I see that there is still a lot of work ahead of us. But yeah, that's something that is in the roadmap that we want to do.
Oh, and just on the personal thing between Sergio and me, if you need help on that, I know this part quite well, so I will be very happy to help on that.
Yep.
Honestly, having a normal GraalVM running should not be hard with custom handlers. Then again, if you want better performance, it's more tricky. Well, well, we need to do work on that on our side also. I'm also pushing, internally on Azure for that. But we have two issues with GraalVM. The first one is that there is not yet a huge market share, so of course it's not pushing as hard as other things. And the other thing is that as you've got a native image, it's very complicated for us to optimize anything because I mean, on our side, we just see a binary. It's like there's the same issue with Docker. You remember at the beginning, you had the choice to upload a Docker container. And when you have a Docker container, we have no way of knowing what's inside it. We're not going to have a look at, at the Docker images of our customers. We don't look at them, So it's your Docker image. We let it like that. So that means that if you run Java inside the Docker image, we can't optimize anything because we don't even know it's Java. We just see an image. So we have less insight about what you are running, and we cannot optimize as well as we can optimize when you are running with a Java worker, like what you were doing here. So not saying it's not possible, it's just more tricky.
Yep.
All right, guys. Well, thank you so much. I think you've gotten all the questions answered, and this has been a very informative session. So I appreciate your time.